Electronics can never be 100% efficient. The lost power is spent as heat. It's generated by electrons moving through materials. And the corollary is that all electronics generate waste heat. Now, the crucial question is, where does this heat go? Heat dissipated at the rate it's generated won't accumulate as raised temperature and isn't a problem. However, with thermal barriers in the design, the temperature at the heat source will keep rising until the thermal gradient is steep enough for the heat to escape, which can cause problems. And this is where our expertise can help. Understanding how to solve, or even better prevent, thermal issues in a design is never a question of one single component, of one single link in the thermal chain. It is a question of understanding the mechanisms of heat transfer, of following the heat all the way from the heat source to the final sink and removing the bottlenecks. We use thermal interface materials to facilitate the movement of heat from one solid body into another. Putting any two flat surfaces together will never yield even close to full contact. In reality, the direct solid-to-solid contact is something on the order of 2 to 4% of the total surface area. The remaining 90-something% will be pockets of air. Air is a brilliant thermal insulator, and in a thermal interface, we don't want that. And that's what TIMs do. They displace the air and replace it with a material with at least 2 orders of magnitude better thermal conductivity. It's all about removing the bottlenecks. Although we specialize in one particular thermal management technology, interface materials, we understand the other technologies involved and how these relate to one another. Therefore, we can assist our customers in their thermal design and guide them to a solution.